If you take your car to a mechanic because the check engine light is illuminated, you expect a certain level of measurable precision.
Oh, absolutely.
Right. You expect them to plug a diagnostic scanner into the dashboard, pull the error codes, and hand you an actual data-driven explanation of what is going wrong under the hood. You definitely don't pay them just to, open the hood, glance at the engine, kick the tires, and say it looks good to them.
I mean, if they did that, you would never go back to that mechanic.
Never.
You were paying for a professional diagnostic, not a visual guess.
Exactly. But every single spring and fall, millions of homeowners pay for an annual HVAC tune-up. It's that routine service we are all told we absolutely have to do.
Right, the seasonal checkup.
Yeah, but for some reason, that expectation of precision we demand from our auto mechanics, it completely vanishes. We end up paying for what is essentially maintenance theater. So welcome to today's deep dive. Our mission right now is to decode a mystery sitting right outside your house, or maybe up in your attic. What are you actually getting when you pay for an HVAC tune-up?
To figure this out, we are pulling from a really fascinating script from a show called Cool Talk with Hartzell.
Okay.
It's hosted by Dave Hartzell, and he's an HVAC veteran with, I think, 45 years of experience based out of Kingfisher, Oklahoma.
Oh, wow. 45 years.
Yeah, he really knows his stuff. And he breaks down the industry's own peer-reviewed benchmark. It's called ACCA Standard 4, or specifically, ANSI-ACCA 4QM4 from 2019.
Okay, let's unpack this, because Dave's breakdown of Standard 4 reveals a startling reality for you as a homeowner.
It really does.
That standard $79 20-minute tune-up that most of us are incredibly used to booking, it is practically a mirage.
It is. We are going to look way past that shiny little date sticker the technician slaps on the side of your condenser unit. We really need to examine the specific measured requirements of what real maintenance actually looks like, according to the industry's own engineering rules.
So let's start with that illusion. I think anyone listening knows exactly what the typical cheap tune-up feels like.
Oh, for sure.
You see an ad for a $79 one special. A technician shows up at your house. If you happen to have a clean air filter sitting in the hallway, they might swap it out for you.
If you're lucky.
Right. And then they wander into the backyard, spray the outdoor condenser coils down with your garden hose, stand there and listen to make sure the fan kicks on, and boom. 20 minutes later, you get a receipt, a sticker, and they drive off to the next house.
And you feel like you did your responsible homeowner duty for the year.
You feel great about it.
But according to Dave Hartzell and ACCA Standard 4, that is not a maintenance visit. That is just a visual inspection mixed with a really basic filter change.
So basically, kicking the tires.
Precisely. Kicking a tire only tells you that it is round and made of rubber.
Right.
It doesn't tell you the tire pressure, the tread depth, or if the alignment is tearing the rubber apart on the highway.
Yeah.
A quick hose down of your AC unit is literally just kicking the tires. Real ACCA 4 maintenance takes 45 minutes to an hour on a normal residential system.
Wait, a full hour?
Yeah, easily. Because it requires specific technical measurements while the equipment is actually operating under a heavy load.
And Daves makes a massive point in the source about why this matters mechanically. He says deferred maintenance is one of the leading causes of early equipment failure.
Yes.
He gives an example of a compressor that is running right at the very edge of its electrical specifications. What does that actually mean in practice?
What's fascinating here is how the physics of this equipment directly impacts your wallet. Think about the condenser coil. That is the big metal box sitting outside your house.
Right, the one making all the noise.
Exactly. Its entire job is to reject the heat that was removed from your home. If that coil is even 30% clogged with dirt, dog hair, or cottonwood seeds, it acts like a winter coat wrapped around the machine.
Oh, wow.
So the compressor has to work incredibly hard to push the heat through that blockage.
So it's essentially struggling to breathe.
Yes. And when a compressor struggles to breathe, it pulls significantly more electricity to do the exact same amount of cooling.
Which means your electric bill goes up.
Oh, way up.
Yeah.
So not only is that compressor overheating and slowly cooking itself to death over a couple of years, but you're also paying for that neglect every single month. Catching that struggling compressor before it dies isn't just a bonus. It is the literal definition of what ACCA 4 is designed to do.
Okay, so if the quick hose down is just kicking the tires, what does a real diagnostic test look like? Because the source material breaks this down into systems. Let's start with the electrical side of things. How is a technician supposed to measure this?
Well, ACCA 4 requires real, hard data. First, the technician must measure the voltage at the unit. And not just the supply voltage when the machine is off, but the voltage under load.
Meaning while the machine is actively running.
Exactly.
Dave also mentions checking the amp draw on the compressor, the condenser fan motor, and the air handler blower. What does measuring amp draw actually tell you? Like, why do we care?
Think of amps as a measurement of electrical effort. When a fan motor is brand new and the bearings are smooth, it takes a very specific low amount of electrical current, or amps, to spin.
Makes sense.
But as that motor ages, or if the system is completely clogged, the motor physically struggles to rotate.
It has to pull more power to force itself to turn.
Exactly. It pulls a higher amp draw. And ACCA 4 requires the technician to actually write those numbers down. They have to compare them against the manufacturer's original nameplate specs.
Okay.
And crucially, against the measurements from previous visits.
Yeah.
By tracking that amp draw over time, you can literally see a motor starting to fail months before it actually seizes up.
That is incredible. It's like, I don't know, watching your cholesterol climb before you actually have a heart attack.
That is a perfect analogy.
Dave also specifically calls out capacitors in his notes. Are those the little silver cylinders that always seem to blow out in the middle of August?
Those are the ones. A capacitor acts a bit like a massive battery that delivers a huge jolt of energy to start your compressor and your fan motors. It is like having a set of permanent jumper cables attached to the system just to get the heavy parts moving. But over time, they lose their ability to hold that charge.
Can you just look at a capacitor and know it's going bad?
Sometimes they bulge at the top when they fail catastrophically, but usually, no. A visual check tells you almost nothing. To do this properly under ACCA 4, a technician must use a specific tool called a multimeter to measure the exact microfarads. That's the capacitance.
Right.
If a tech walks up to your unit empty-handed without a meter, they simply cannot do this job. Period.
Okay, so that is the electrical system, the heartbeat. But what about airflow? Because the standard gets very specific about this, and this is where I actually found myself getting a little confused or maybe just frustrated by the industry norm.
Let's talk about it. The standard requires checking that both the supply and return airflow are adequate. A technician has to check for blocked registers, verify the air filter is clean and installed correctly, and check any accessible duct connections for severe leaks.
Right, but the most critical part of the airflow check involves the evaporator coil, right? That is the indoor coil, usually sitting on top of the furnace in the closet or up in the attic.
Yes, ACCA 4 demands verifying that the evaporator coil is clean. Because a dirty evaporator coil physically blocks the air from moving through your house, which immediately collapses the efficiency of the entire system.
Wait, I need to stop you right there.
Sure.
I have definitely had HVAC companies come out to my house for a standard tune-up, look in my attic, and tell me that cleaning the evaporator coil is going to be an extra $150 or $200. If cleaning that coil is explicitly included in the scope of a complete maintenance visit under ACCA 4, why is it treated like a premium add-on? Is the standard just a suggestion?
It's an industry-wide unbundling tactic, and it is incredibly common. Companies will advertise that $79 special just to get a foot in the door.
Right.
But $79 doesn't cover the labor time required to do actual ACCA 4 maintenance. So they unbundle the standard, they strip away the coil cleaning, and charge you extra for the actual maintenance work that the standard dictates should have been included in the first place.
That feels entirely deceptive.
It is, because without proper airflow over a clean coil, the system just cannot function as designed. Tracing performance issues back to their root cause, like realizing a high electrical amp draw, is actually being caused by a dirty coil, choking flater. The airflow is the core principle of ACCA Standard 4. Everything is connected.
Okay, so we have the electrical data and the airflow data. This leads us to the refrigerant. And honestly, this brings us to what might be the single most persistent, expensive myth in the entire HVAC industry.
Yeah, the refrigerant check is unfortunately where a lot of homeowners get taken advantage of. ACCA 4 requires evaluating the refrigerant system by checking operating pressures. They have to evaluate the superheat or the subcooling to confirm the refrigerant charge is correct for the weather outside on that specific day.
Okay, let me pause you. Superheat and subcooling sound like terms from a sci-fi movie.
They do.
What are they actually measuring? Is it just checking the temperature of the air blowing out of the vents?
Not quite. Think of refrigerant like a liquid sponge that constantly travels back and forth between the inside and outside of your house.
Okay, a liquid sponge.
When it comes inside, it expands and absorbs the heat out of your air. Then it travels outside, compresses, and squeezes that heat out into the atmosphere.
I like that analogy, so it's constantly wringing itself out.
Exactly. Superheat is basically a mathematical measurement of how much extra heat that sponge has absorbed after it has already boiled from a liquid into a gas.
Oh, I see.
And subcooling is the opposite. It's how much it is cooled down as a liquid. By measuring the exact temperature of the copper pipes and comparing it to the pressure inside those pipes, a technician can prove mathematically if you have the precise amount of refrigerant in the system.
And if those numbers are off, do they just add more refrigerant?
No, and this is crucial. If the numbers are off, ACCA 4 dictates that the technician must look for signs of leaks, things like oil staining, frost patterns, or abnormally low pressures.
Here's where it gets really interesting. Refrigerant does not wear out.
It does not.
Yeah.
It does not get used up over time like gas in a car engine. It is a completely sealed, closed-loop system.
So if your system is low on refrigerant, that means there is a physical hole in the loop somewhere.
Yes.
Which means if a technician comes out every spring and tells you, hey, you're a couple pounds low, let's just top it off, they're essentially putting a Band-Aid on a leaking tire, refilling it with air, and pretending they've fixed the puncture.
This raises an important question, though. How many consumers out there are tricked into paying hundreds of dollars for annual refrigerant top-offs year after year?
Millions, probably.
Right, but ACCA 4 is crystal clear. Adding refrigerant without identifying and fixing the source of the leak is not maintenance. It is a temporary patch. Systematic diagnosis requires tracking the issue back to the leak, not just guessing and charging you for a top-off so the unit limps through the summer.
That is incredibly frustrating, but knowing that the physics don't lie is so empowering.
Absolutely.
Now, up until this point, we have been talking mostly about efficiency. We're talking about saving money on parts, avoiding high electric bills, and not getting scammed on refrigerant. But Dave transitions into a part of the standard that is much more serious. Skipping air conditioning steps costs you money, but skipping heating and water drainage steps can physically damage your home or put your life at risk.
This is where we look at gas furnaces and condensate systems. Let's start with the gas furnace. The most critical component inside a furnace is the heat exchanger. ACCA 4 demands a heat exchanger inspection on every single gas furnace maintenance visit.
What exactly is a heat exchanger?
It is the metal chamber inside the furnace where the gas actually burns. It gets incredibly hot. Your blower fan pushes the air from your house over the outside of this blazing hot metal chamber to warm it up.
Okay.
But the toxic exhaust fumes from the fire stay safely sealed inside the chamber and are vented out your roof.
So the stakes here are quite literally life and death. If that metal cracks, that sealed barrier is broken.
Yes. A cracked heat exchanger allows carbon monoxide, which is a deadly odorless gas, to mix with the air that is being blown directly into your living room.
How do they even check for a crack? Do they just shine a flashlight in there?
Standard inspection methods required by ACCA 4 do include a visual inspection using a mirror or a snake camera, but they also require watching for something called flame disturbance when the blower engages.
Flame disturbance, what does that look like?
Imagine there is a hairline crack in the metal. When the powerful blower fan kicks on to push air into your home, that air pressure pushes violently through the crack and into the combustion chamber.
Oh, wow.
Yeah. If a technician is watching the gas flames when the fan starts, and those flames suddenly dance, flicker, or flatten out, they know immediately that air is pushing through a crack. It's a telltale indicator.
That is terrifying. But Dave notes that visual inspections alone, even watching the flames, just aren't enough.
Right. Visual checks fail to spot invisible gases. That is why ACCA 4 relies on hard data. For gas equipment, the standard requires checking the gas supply pressure and measuring flue gas temperatures. But the most important tool is combustion analysis.
What does a combustion analysis actually measure?
It involves a specialized electronic analyzer that actively measures the levels of carbon monoxide, carbon dioxide, and oxygen in the exhaust gas. Dave says he runs a combustion analysis on every single furnace he services.
Really? Every single one?
Yes. Because a furnace can look totally fine, light up perfectly, and heat your house without a single dancing flame, but still be running improperly, burning too much gas and producing dangerous levels of carbon monoxide.
So if a technician comes to your house for a winter furnace check and doesn't even mention the heat exchanger, or they don't bring in an electronic analyzer to do a combustion analysis, alarm bells should immediately start ringing.
Absolutely.
Yeah.
You cannot eyeball carbon monoxide. If they aren't using an analyzer, they are guessing about your safety.
Okay, what about the other hidden hazard Dave mentions, The condensate system. I always assumed that was just the little PVC pipe dripping water outside.
Well, it is. The condensate system handles the moisture that your air conditioner pulls out of the humid indoor air. ACCA 4 includes checking the condensate drain line and the drain pan under the unit.
Okay.
If that drain pipe gets blocked by algae or dirt, the water backs up. You are looking at major water damage to your ceilings if the unit is in the attic, or ruined floors if it's in a closet.
Doesn't the system have a safety switch for that?
It should have a safety float switch. If the water backs up, the switch floats up and shuts the entire system down to prevent a flood.
But if that float switch trips, you have no air conditioning.
Correct. And Dave points out that in central Oklahoma, or anywhere really, in the middle of August, having your AC shut off entirely because of a clogged drain line is not just a minor inconvenience.
No, it's miserable.
Right. It is an emergency that could have been completely prevented with 10 minutes of actual maintenance during a spring visit.
Okay, so we've broken down the illusion of the cheap tune-up. We understand the electrical amp draws, the airflow, the sponge physics of the refrigerant, and the hidden safety dangers of carbon monoxide. So what does this all mean for you as a homeowner? How do you actually use this knowledge to evaluate your own maintenance plans or your current service providers?
The source material provides a very clear blueprint of actionable questions every homeowner must ask their HVAC company. First, ask, what electrical measurements are taken on each visit?
Right.
If they don't explicitly tell you they measure voltage, amp draw, and capacitor microfarads, they are not evaluating the electrical system. They're just looking at it.
Question 2. Is refrigerant evaluated on every visit? And Dave notes that this is true even for heat pumps, which need their refrigerant evaluated in both heating and cooling modes.
Third, ask, is evaporator coil cleaning included? If they say it is an extra charge, now you know they're unbundling the standard
And
and you aren't getting a complete tune-up for that baseline price.
wow, that's a great test.
And fourth, if you have gas equipment, ask, how is the heat exchanger inspected? If they don't mention combustion analysis, that is a massive red flag for your safety.
But Dave says the ultimate consumer protection comes down to the paperwork, documentation.
Yes, ACCA 4 requires documenting actual measured values. A checklist with a bunch of boxes that just say checked or okay does not meet the standard.
Not at all.
The homeowner must be given a report with the hard data. You need the exact amp draws and the exact capacitance reading so you can track the health of your system and compare this year's numbers to last year's numbers.
Dave actually talks about how his own company handles this. They run something called Dave's 360 plan, which is explicitly built around ACCA 4 requirements. It's a full 45 to 60-minute visit.
Yeah.
They document the quotes. They use a $111 diagnostic fee approach that is totally systematic. They don't guess, and they don't invent problems because the math dictates what is broken and what isn't.
If we connect this to the bigger picture, knowing about ACCA 4 radically shifts the power dynamic. It takes the homeowner from being a passive payer who just crosses their fingers and hopes the technician did a good job and turns them into an informed consumer. You now have a verifiable, measured standard to hold contractors accountable to.
Which is incredibly powerful. Knowing what this standard demands directly protects you. It protects your wallet from paying for premature compressor failures and high electric bills, and it protects your family from serious safety hazards like carbon monoxide. True HVAC maintenance is about taking specific operating measurements. It is about finding the root cause of an issue like tracking down a refrigerant leak rather than just topping it off with a Band-Aid.
And above all, it's about verifying performance and safety through hard data.
And it all comes back to that expectation of precision we talked about at the start. You wouldn't let a mechanic just look at your car engine and guess what's wrong, so you shouldn't let an HVAC technician do it to your home either. The next time a technician hands you a receipt that simply says checked, okay, will you ask to see the actual numbers? And if they don't have them, what else in your home are professionals just eyeballing when you're paying for precision?